Day and night, the world's most powerful bucket wheel excavators work their way through the sandy ground in Hambach near Cologne in Germany, harvesting the brown coal needed for power generation. The 3 open-pit mines owned by the RWE Power Company produce more brown coal than any other in the world, roughly 100 million tons annually. At over 8,500 hectares, the Hambach open-pit mine is the largest and deepest mining region in Germany. More than 40 million tons of brown coal are mined there each year. That brings up to 300 million tons of overburden to be removed as well. A hydraulic steering mechanism ensures the BG290 bucket wheel excavator navigates precisely through the grounds. The giant equipment stands on 3 crawler bases consisting of 4 crawler units apiece, splitting the 13,500-ton load between them. The movement is controlled using one single crawler base maneuvered via a steering shaft by an enormous hydraulic cylinder. The cylinder weighs 30 tons with a piston diameter of 1,000 millimeters and an overall stroke of 4,400 millimeters. To achieve these turning forces, 4 axial piston pumps are employed on an aggregate unit with a total output of 500 liters of hydraulic fluid per minute. During excavator operation, individual stones frequently fall onto the half-extended piston rod when it is in the straight-ahead transport position. Over decades of operation, the chrome surface has become covered with impact points. Yes, after 28 years of operation under what are quite rough open-pit mining conditions, strong abrasive wear is evident here, particularly on the piston rod, primarily caused by spillage. Points of impact that mean that the seal can no longer work according to its design, so that leaks have formed that naturally have to be closed off for good. In the end, the leak was so extensive that even as early as 2005, the experts from RWE Power Company began looking for an able service provider for the reconditioning of the 40-ton cylinder. The cylinder had to be dismounted and then really reconditioned, and so then we had to start looking around to see who had the competency to do this kind of thing. A partner who had the technical know-how and in particular could act within the tight deadlines of our planned shutdown. Adherence to that tight time envelope was an important aspect in the selection of a contractor to conduct repairs. The program called for 21 days of downtime during which the cylinder would be dismounted, reconditioned, and remounted so that operations could then resume. There are no redundant systems in open-pit mining, which means if one floor level remains in place while the excavator is being reconditioned, then the other levels start piling up until at some point the entire open-pit mining comes to a standstill. But the coal is needed, so naturally you have to take advantage of that tight window of time. The following requirements had to be fulfilled: renewal of the sealing elements and guideways, design and manufacture of a protective cover against falling stones, recoating and repair of the piston rods through a chrome nickel layer, replacement of the spherical bearing, honing of the cylinder tube, renewal of the anti-corrosion coating and sandblasting, inspection and reconditioning of the valves mounted on the cylinder, pressure testing and refilling with hydraulic oil. On the basis of numerous preparatory discussions, site visits, and repair proposals, RWE Power Company decided in spring 2006 to have the cylinder reconditioned by MontanHydraulik Repair and Service GmbH, MRS for short. Preparation work for the repairs, already scheduled for late August, had to be pushed forward quickly. An operation plan for the project was created to provide an overview of all necessary steps. Measures that could run parallel to one another were planned correspondingly. Staffing from among the master craftsmen was planned down to the smallest detail so as to optimize the utilization of all possible resources during the tight time envelope. Sufficient space was freed up for the assembly work in the large hall near the testing stand, thereby allowing all work to be conducted within the reach of the 40-ton crane. A hydraulic extraction device for replacing the spherical bearing was designed and built. Specially produced support stands were provided for the mounting and honing work. At the same time, the MontanHydraulik Engineering Center in Holzwickede begins work on designs for a suitable protective cover. Together with MRS and a seal manufacturer, a new sealing solution was conceived. On August 22nd, things get underway. In Hambach, dismounting work on the cylinder started, a job that would last long into the night. The cylinder reaches Dortmund the next morning, with disassembly beginning immediately. The first step is to loosen all screws and nuts. Thereafter, the rod is slowly removed from the cylinder tube along with the cylinder head and piston. Then the rear spherical eye is dismounted. Finally, the piston rod package is hung on the hooks of 2 overhead cranes and is carefully laid onto the previously arranged support stands. The individual components are inspected for damage, and the cylinder pipe is measured precisely. The spherical bearing is pressed out of its bearing seat using specially prepared equipment. The piston must first be dismantled before the cylinder head can be disassembled. You have to imagine it like this. We pulled the piston rod completely out of the cylinder and then laid it on the jig. And then we warmed up the piston and we wanted to unscrew it with the overhead crane. So we put a rope around it and unscrewed it. The piston only turned for a few pitches of thread before biting firmly into its fitting and refused to move another millimeter. A decision had to be made quick about how to proceed further without losing too much time. The piston rod must be on the truck no later than Saturday afternoon in order to arrive on Monday morning at the coating company in Italy. The night shift has to be responsible for loosening the piston completely from the rod. The only chance we have here is torch cutting. And to do that, we need to bring in the necessary materials, additional torch cutters, extra workers, and then we have to succeed at getting the piston off the rod on Saturday morning. We had to make a decision. When we noticed that the piston was stuck and knew that we had to deliver the thing to Italy the next day or else the entire schedule would be ruined, a decision had to be made. So we made the decision that we had to torch cut the piston. But burning through a meter of steel is no easy task. The work progressed slowly, not last because of the very sluggish flow of dross. When you work with oxygen lances, an incredible amount of slag forms, and the piston had a hollow space on the inside, but we couldn't see from the outside that the slag had run in there. And when it was full or had filled up, then the slag started coming out. You can push the slag out because with oxygen lances you are always working with thrust, and then things went better. It was Saturday morning before the last piece of piston fell off the rod seating. The transport left on time, everything worked. The rod was sent for the coating, and at the same time, we began to manufacture the piston. We ordered material, drew up the blueprints so that the piston would be available in time for the return of the rod for assembly. MRS employee Danny Bach accompanied the rod on its way to Italy for the welding and resurfacing of the impact points. I drove to Italy because there were a lot of holes in it, and I was supposed to machine them. The rod had a lot of holes, including very big ones as well, around 170. I welded them with an electron welder and then did the reconditioning with a hand grinder. The rod was then packed onto a grinding machine with a grinding stone, which means that they could really build up some pressure against the rod and grind away the small holes. While the rod is being coated in Italy, in Dortmund work is underway on the cylinder tube. A new protective coating is applied to the tube. Before welding is performed, a spectrometer is used to examine the tube material before the guide rails for the protective cover are welded on. The interior surface of the tube is completely honed. The piston is manufactured completely new. The arrival of the piston rod in Dortmund on Thursday afternoon marks the start of a race against time, because the cylinder is due to be back in Hambach on Saturday. The threads on the rod and piston are lined up again. It is a tense moment. Will they fit each other? There's only one go-through on this. If they stick, then the work will be delayed by at least a week. A sigh of relief. The threads fit. The cylinder receives another protective coating. The mounted piston rod package is pushed into the cylinder tube. The cylinder head is mounted. At the same time, last coating applications and the installation of valves and tubing is undertaken. Finally, the protective cover is mounted and adjusted. The cylinder is bled, filled with 2,500 liters of hydraulic oil and pressure tested. On September 16th, precisely 25 days later, the cylinder leaves Dortmund in the gray of morning and is driven back on a special transport to Hambach for assembly. It is first reloaded onto a special all-terrain vehicle that brings it back to the bucket wheel excavator. Installation is begun immediately. On Monday morning, the BG290 is ready to resume its regular work.